Hello learners, I am Mohini Arora, I am HOD Computer Science and today I will be discussing with you the topic of computer fundamentals. After going through this video, you will be in a position to know the basic components of a computer, you will know the input-output devices, you know their functions, and after that we will also be discussing about the storage devices. I really hope that it will be a very valuable session for you. So, let's just start with it. First and foremost, as this slide shows, that a computer works with both hardware and software. So, without the hardware, the software is non-functional. Without the software, the hardware is non-functional. The combination of two actually makes the working of a computer. And if we go ahead, before moving ahead, let's first see what is a hardware, what is a software. A hardware consists of mechanical and electronic devices which we can see and touch. For example, you can see the keyboard, you can see the mouse, you can see the monitor, all these are hardware devices. We talk about software, it consists of programs, the operating system, the data that resides in the memory and storage devices. Say for example, if I take a compact disc, the compact disc itself is hardware, but the programs, the songs, the movies that are stored inside it are software. So, after this particular discussion of hardware and software, let's move on to the next slide. This slide shows the block diagram of a computer. It is the basic functioning of a computer. How does a computer work? Every computer consists of an input unit, a central processing unit, an output unit and memory of course. Input unit is one which helps us to accept data from the user. Data can be accepted in many forms, in text, in audio, through pictures, anything. There are various devices, input devices that help us to accept data from the user. We will be covering these devices during the course of the session. Then we have the central processing unit. Central processing unit which converts this data that has been accepted into output, the output that we want. So, this is basically the processing unit which converts input to output. In the course of processing, we need memory to store data. So, the central processing unit is in direct connection with memory registers which helps to store data. And finally, to see the results of the processing, we have the output unit. There are various output devices that help us to see the results, see the outcome of the process, like monitor, printers, plotters. We will be covering them also during the due course of time. So, in a nutshell, if I talk about the working of a computer, the first step is receiving the input, that is accepting data and information from the user through input devices. Second step is processing that information through arithmetic and logical operations. Third step is storing that information in memory devices like hard disks, CDs, pen drives, etc. And finally, the information, the final output is communicated to the user through output devices like monitors, printers, plotters, etc. So, after this, seeing how the computer works, let us see what are basic components of a computer. We have input devices as discussed before, as seen in the previous slide also, input devices to accept input, central processing unit which converts that input into output, memory that stores the data that is being processed, and the output devices which help us to get the final result. Let's discuss these components one by one in detail. First and foremost, we start with the input devices. As told to you before, these are the devices that accept data and instructions from the user. Some of the commonly used input devices are shown in this slide. We have the keyboard, mouse, OCR, MICR, OMR, barcode reader, digitizing tablet, scanner, light pen, microphone, web camera and joystick. You must have seen various other devices also that help in accepting input from the user. Let's go through these commonly used devices. First and foremost, the keyboard, most commonly used input device. It helps us to key in the data. You have various keys on the keyboard. Normally, we have a QWERTY keyboard with 104 keys, and we have alphabet keys, number keys, special purpose keys, function keys. Below the QWERTY keyboard on this slide, you must be seeing a different fancy keyboard. This is the multimedia keyboard. It has some new keys on it which helps us to play audio and video. But generally, every keyboard has these keys, typing keys which are alphabets and numbers. We have a numeric keypad on the corner of the keyboard. This keypad contains the number keys. Then you have function keys which are meant to perform specific functions. You have 12 function keys. You have control keys like home, end, delete, backspace, page up, page down, etc. And you have certain special purpose keys like enter, shift, caps lock, num lock, space bar, etc. Every key has a specific function to perform. Once you start working with the computer, you come to know what specific function the key performs, and you learn the function of these keys in the due course as you learn typing, as you start making programs, as you start making documents. You slowly keep on learning about various functions of these keys. Next input device that we will be covering is the mouse. Again, a very common scene, a very common device you must have seen around your computer. It is a pointing device, and it generally has two buttons, left and right buttons, with a scroll bar in the middle. It generally is used to perform functions like selecting menu commands, moving icons, resizing windows, starting programs, choosing various options, and so on. Next, we have the OCR, the optical character recognition, a device that is used for reading text from paper and translating the images into a form that a computer can understand. You must have heard about various books that are being converted to digital form. The device that is used to do this is the OCR. The pages of the books are scanned and converted into various digital forms as required. We can form a text file, we can form an Excel file, we can form a PDF file by scanning through the OCR. So, an OCR is basically used to convert books, magazines, and other such printed information into digital form. Next input device is the magnetic ink character recognition, commonly known as MICR. It is again a device that is used to identify characters printed with a special magnetic ink. And the common place where you must have seen this is the check. The banker's check contains the MICR number below it. It is shown in this slide also. Whenever you deposit the check, this number is scanned by the device to verify the authenticity of the transaction. So, a very useful device for banking transactions is the MICR. Next input device that we will be covering is the optical mark recognition. Again, this is a mark sense reader, and this technology is used for evaluating all the multiple choice questions examinations. This technology helps to sense the presence or absence of a mark such as a pencil mark, as it is shown in this slide also. An OMR sheet is shown, and the OMR machine is sensing this sheet to verify how many answers are correct, how many answers are wrong. So, this is very useful for assessing the objective examinations involving multiple choice questions. Next device is the barcode reader. After the digitization of the e-commerce, barcode reader is again becoming a very common scene. You must have seen this device in malls, in departmental stores for the billing operations. This device is used in supermarkets, in libraries, and it reads the barcodes. The slide here shows the barcode and the scanner also. By scanning through the barcode, the device checks out the price, description, any discounts if there are on the product, and helps to form easy billing at a store that we are shopping in. Next device is the digitizing tablet. It helps us to enter drawings and sketches into a computer. It is a tablet basically with a cursor and a pen. A cursor is just like a mouse and a pen is just like a stylus. You can draw directly on the screen. You can see in the next slide the tablet. The upper tablet is containing a pen. You can directly draw on that tablet, and you have a mouse shaped puck also, which helps you to choose between various options. So, it is a very useful device for the designers who would like to draw on the machine and capture the electronic form rather than making on the paper and then getting it scanned. So, this is what is a digitizing tablet. Next device is obviously a scanner. It converts images to electronic format that can be stored in computer's memory. Basically, when you keep any picture or a page in a scanner, it divides it into grids of boxes, and each box is either a 0 or 1 depending upon whether the box is filled with some material or not. So, this digitized form is saved into a picture. The scanner converts into a picture form only. So, you cannot have textual data in the form of text. Even if you scan the text through the scanner, then also you will have a photo picture only, which can be cropped, which can be resized, which can be given various effects, but yes, it cannot be edited as the text is edited. So, that is what is the peculiar property of a scanner. Then the device that you now see on the screen is the light pen. Again, a pointing device similar to the pen, used for drawing objects or pointing on the screen. Again, used by designers to directly make markings on the screen, to directly draw a particular figure on the screen is the use of the light pen. A microphone, again a commonly seen device. It takes sound and voice as an input. You can see the two different types of microphones on the screen itself, the handheld one and the desktop microphone, which is generally fixed on the desktop. You can record your sound through the microphone and save it in the form of the audio files for future use. Then you have some other input devices which you can see around you. You have the trackball, you have the webcam. Webcam is very commonly being used nowadays to capture video, especially with the video chat feature being enabled almost everywhere. So, webcam is a useful device to capture the video. You have the joystick, which is used to play games. So, these are various other input devices that can be attached along with the computer to accept input from the user in various forms. So, having covered with input devices, you are now well aware with how data can be accepted from the user. So, after accepting data, next step is the processing of the data. And to process the data, we have the central processing unit or the CPU. CPU is indeed and very commonly referred to as the brain of your computer. It processes or executes the instructions given to the computer. A CPU is based on a single chip. It is known as microprocessor, and such computers which have microprocessors in them are microcomputers. And a typical CPU has the following components. It has the control unit, it has the arithmetic logic unit, and it has the memory registers. So, let us see these components of the CPU one by one. First, we talk about the control unit. As the name says, the control unit manages the instructions given to the computer. It controls the entire functioning of the computer. It coordinates the activities of all the other units in the system. It instructs the components of the computers how to carry out the instructions. It reads and interprets instructions from memory and transforms them into series of signals to be executed and stored. So, which instruction will be executed when, where it will be stored, how the output will be delivered is all decided by the control unit. It directs the movements of these electronic signals between memory, ALU, or between CPU and output devices. So, entire processing is actually controlled by the control unit. That is why the name control unit. Next, we move on to the next component of the CPU, which is the arithmetic and logic unit. It is basically performing two types of operations, arithmetic and logical. Arithmetic operations, these are the fundamental mathematical operations, addition, subtraction, multiplication, division, shifting, and so on. And logical operations are basically used to handle two or more instructions at one point of time using and, or, and not operators. So, ALU is basically helping us to get the result out of a particular instruction using any of the operators required. What operators are required, what operators will be used is decided by the ALU according to the instructions given by the user and the instructions interpreted by the control unit. Then we have the memory registers. Data, if entered for processing, has to be stored. It has to be held up by the computer so that the result can be calculated. That storage of data is done by memory registers. These are basically a sort of special storage area that holds the data and instructions temporarily during processing. Please note the word temporarily is very important here because the data and instructions are stored only till the time they are being processed. Once they are processed, the result is communicated, these registers lose their data. These are internally located in the CPU, so obviously the processing time is very less. The time that is spent between fetching of data from ALU to the registers and vice versa is less. They often hold data for less than a millisecond. Obviously, that is the speed expected out of a computer. So, the data, once the instructions are executed, are processed, the memory registers are freed for further execution. Data stored in the locations are known as addresses. Every location is given a unique number that we call as the address. That is how the control unit designates and decides where the data is being stored, where the result is being stored, where the internal processing is being stored, and so on. And the contents of the memory are held only temporarily, as discussed before also, as long as the computer is turned on, as long as the data is not permanently stored in a device so that it can execute next set of instructions. So, this particular slide shows the basic working of CPU and memory. As you can see in the block diagram here, that through the input unit, program and data are accepted. The CPU accepts that data with the help of its components, that is the control unit, ALU, and memory. This data is processed and stored. Finally, as instructed by the user, this data is directed towards the output devices for the user to view the results. So, this block diagram sums up the entire working of the computer along with memory, along with the devices, input devices and output devices. Let's have a small example that I have given here in this particular slide. Say there is an instruction to perform arithmetic calculation on a particular set of numbers. So, the first instruction that will be given is the program tells the user enter the first number. User types the number through the keyboard obviously, and as he types the number, presses the enter key, the electronic signal is sent to the CPU. The control unit recognizes the signal and routes that signal to the address, to the memory. Say a particular address is designated by the control unit. An example that is shown on your slide gives the address as 7. After comparing the instructions, the next instructions tells the user to enter the second number because we have to add these numbers. So, 2 numbers are required. The user types the second number and again a signal is sent to the CPU. The control unit again routes that particular signal to a memory address, say suppose 8. Once both the numbers are received, we need to multiply them. So the control unit sends to the ALU a copy of the contents of the address 7, which was having 100, and address 8, which was having 4. That is, the first number was 100, second number was 4. So now ALU has the entire instructions and data. It has got the instructions to have two numbers, that is 100 and 4, and it has the process instruction that the multiplication has to be done. So ALU performs the multiplication. The control unit then sends the copy of the result, which is obviously 400, to the memory to store it at a particular address. And then the next instruction, the final instruction to print the result, is executed. The control unit sends the contents of address 9, where the result was stored. 400 was stored, to the monitor, and monitor displays the value 400. So final instruction end comes up and the program is complete. So this example was a very basic example that showed you how a simple instruction to multiply two numbers is executed sequentially by the computer, starting from the input, coming on to the CPU, and finally displaying the output on the output device. In this particular session, through the video, you have learnt about the working of a computer. We went through the block diagram of the computer, which explained the basic components and the operation of a computer. And finally, we did some commonly used input devices which help us to give instructions, to give data to the computer in various forms, may it be text, may it be images, may it be pictures, and so on. I hope you enjoyed this session and it was fruitful to you. Thank you.